For 70 years, America dominated Antarctic research. 3 permanent stations, over 100 buildings at McMurdo Station alone. The largest logistics hub on the continent. Research vessels and icebreakers keeping supply lines open year-round. More than 1,200 scientists and support staff during peak season. It was infrastructure on a scale no other nation could match. By 2019, much of that infrastructure was falling apart. Buildings designed for 20 years had lasted 50. So, the United States launched a $410 million modernization to secure America's Antarctic future. But something entirely different is happening. And here's why. At the bottom of the world sits Antarctica, and scattered across its ice sheet are 3 American research stations. Palmer Station on the Antarctic Peninsula, 46 people, 24 buildings focused on marine research. Amundsen Scott South Pole Station at Earth's southernmost point, 2,835 meters above sea level, where the ice beneath moves 10 meters per year toward the ocean. And then there's McMurdo Station, the largest of them all. 146 buildings built on volcanic rock and permanent ice. 1,200 residents during summer. A hub that makes everything possible. McMurdo wasn't built following a master plan. The United States established it in 1956 as a small outpost. Then, as demand grew, so did the station. Buildings were added wherever they fit. A laboratory here, a warehouse there, a dormitory somewhere else. Over the decades, what started as a research station evolved into something else entirely. A fully functioning town. The largest city in Antarctica. The logistics of running this place are unlike anywhere else on Earth. Everything, supplies, equipment, fuel, has to be shipped 15,000 kilometers from the United States. There's no local supply chain in Antarctica, no hardware stores, no fuel depots, no restaurants. Materials have to be ordered at least a year in advance. A year! You can't just decide you need a specific bolt in June and have it arrive in July. If you forget something, you're waiting until next season. That's 12 months of delay for a single overlooked item. And then there's the construction window. You've got 6 months, the austral summer, to get anything done outdoors. Outside that window, impossible. Temperatures plunge to minus 40 degrees Celsius during winter. The ice becomes too unstable. The darkness is complete. The engineering challenges make it even harder. Foundations must be anchored into permafrost or drilled through volcanic rock. Steel becomes brittle in extreme cold, so structures need specialized alloys. Every building sits on adjustable supports to prevent melting ice from causing collapse. At the South Pole, the entire station is elevated, designed to be jacked up twice during its lifetime as snow accumulates around it because the ice beneath is constantly moving. Construction crews work in conditions that would shut down any normal job site. Winds hitting 100 kilometers per hour, whiteout conditions with zero visibility, temperatures that freeze exposed skin in minutes. The annual operations budget? Over $200 million. Fuel alone costs $4.70 per gallon, not because Antarctica has expensive gas stations, but because every drop must be shipped across an ocean. Even routine maintenance becomes extraordinarily expensive when the nearest hardware store is literally on the other side of the planet. This is engineering at its limit, not only because of the harsh conditions, but because of the isolation, because of the logistics, because of the scale. McMurdo isn't just maintaining buildings and equipment, it's maintaining an entire functioning society in the harshest place on Earth. For nearly 70 years, the United States pulled this off. Not just McMurdo, but 3 permanent stations. Multiple research vessels, icebreakers keeping supply lines open, thousands of scientists rotating through every year. It was infrastructure on a scale that no other nation could match. And it worked. But maintaining it came at an enormous cost. And that cost was about to become unsustainable. McMurdo wasn't designed to last forever. It was designed to last 20 years. That was 1956. By 2019, McMurdo's liability had become catastrophic. It's now 2025. You do the math. The buildings are falling apart. Freeze-thaw cycles have weakened concrete floors so severely that forklifts punch through warehouse surfaces. Snowdrifts pack so densely under doors that heating systems can't maintain room temperature. Thermal surveys revealed significant heat loss through building envelopes and the deteriorating utility corridor network. But the buildings are just the beginning. The ice pier is McMurdo's lifeline. Every year in January and February, a supply ship docks there to offload fuel, food, equipment, and cargo, everything McMurdo needs to survive another year. Except the pier keeps failing. Between 2012 and 2023, it collapsed 5 times in 10 years. Each failure meant emergency helicopter missions to rescue stranded cargo or leaving supplies sitting on the ice, exposed to the elements, waiting for the next season. Each emergency cost millions of dollars and threatened the entire research program. Why does it fail so often? The ice pier is essentially a massive floating ice cube, 550 feet long, 250 feet wide, 20 feet thick, reinforced with steel cables and wooden bollards. In the early days, piers lasted 7 to 10 years. Now, because of warming temperatures and operational wear, they last about 1 year. The recent average lifespan is approximately 1 year. The power infrastructure is on borrowed time too. According to the National Science Foundation, NSF own assessments, the station's control systems manage 8 diesel generators and 3 wind turbines with no backup redundancy. If one fails, there's no automatic failover. Medical operations shut down. Fire protection fails. Communications fail. This isn't speculation. It's documented in official NSF reports as unreliable systems with frequent outages. Water systems face similar pressures. Desalination units produce 277,000 litres per day from seawater, but the pipes freeze. The distribution network corrodes, and wastewater treatment, once limited to simple maceration and direct discharge into McMurdo Sound, now requires complex treatment plants that were never designed to operate efficiently at minus 40 degrees Celsius. And the ships that supply McMurdo? More than 2/3 of the USAP, United States Antarctic Program research fleet, the vessels that bring scientists and supplies to Antarctica, are beyond their end of life, in some cases by decades. These are ships that were supposed to be replaced 10, 15, sometimes 20 years ago. Even the South Pole Station, 1,400 kilometers inland, faces its own crisis. The station's infrastructure is literally being crushed by the weight of snow, accumulating at 1 meter per year, while the utilities beneath the ice are aging beyond repair. There's a cruel irony embedded in McMurdo's bones. It was built as Cold War infrastructure. Between 1962 and 1972, the US operated the PM-38 nuclear reactor on site, one of the only nuclear plants ever built south of the 60th parallel. They decommissioned it decades ago, but the sprawling, inefficient thinking that shaped its construction never went away. The fundamental problem is the layout itself. Scientists currently must visit 16 disparate locations across the station to perform their daily work. Individual buildings operate as isolated systems rather than an integrated complex. Heating systems, utility distribution, and supply chains create redundant pathways. The result is a town that wastes enormous amounts of energy when consolidated systems would be far more efficient. By 2019, all these failures added up to a single, undeniable truth. McMurdo had reached a breaking point. The NSF's own assessments made clear that patching these problems would become exponentially more expensive than rebuilding the entire station from scratch. The United States had a choice: accept that McMurdo was becoming unsustainable, or transform it completely. They chose transformation. In 2019, the NSF announced AIMS, Antarctic Infrastructure Modernization for Science, a $410 million plan to rebuild McMurdo entirely. Here's what AIMS was supposed to accomplish. Instead of maintaining 100-plus aging buildings scattered across 49 acres, the plan would consolidate major operations into just 6 state-of-the-art facilities connected by efficient utility corridors. Each building was designed with cutting-edge Antarctic engineering. The scale was ambitious. The core facility, 261,000 square feet, would consolidate station management, administration, food services and dining, fire department, medical facilities, recreational space, and all the shops into one integrated hub. Imagine 4 Walmarts combined into a single building. Everything is interconnected. Everything is accessible without going outdoors. A 285-bed lodging facility would replace scattered dormitories, saving 41,371 gallons of fuel per year just through energy efficiency. An emergency operations center for fire protection and medical emergencies, a field science support center for communications and field equipment, the vehicle equipment operations center, McMurdo's main maintenance facility, where the entire station's fleet could be serviced. Each building would feature revolutionary engineering, a strong thermal envelope, heavily insulated walls and roofs designed to minimize heat loss in minus 40 degrees Celsius conditions. Thermal bridging was completely eliminated through specialized wall assemblies. Condensation, where moisture freezes on interior surfaces, was engineered out through advanced vapor barriers and ventilation systems. Energy efficiency was revolutionary. The new facilities would use 36% less energy than existing McMurdo buildings and 27% less than industry standards for cold climate construction. The power infrastructure would be completely reimagined. Instead of 8 aging diesel generators operating independently, AIMS proposed a combined heat and power system, capturing waste heat from generators that currently dissipates into Antarctic air and reusing it to heat buildings. Wind turbines would be upgraded from 990 kilowatt capacity to 3 megawatts of generation, with battery storage so excess wind power could be stored instead of wasted. Solar panels would finally arrive in Antarctica. For the first time, McMurdo would have renewable energy as its primary power source, not a backup. The vision was transformational, a research station powered by the sun and wind, not diesel dependency. The water and waste systems would be consolidated. Instead of fragmented desalination units, isolated treatment plants, and 16 separate locations scientists had to visit, a single integrated facility would handle all water production, distribution, and wastewater treatment. One unified system. Maximum efficiency. Zero redundancy waste. The footprint would shrink dramatically. AIMS would compress McMurdo's sprawling 49 acres into a consolidated, efficient campus. The station's physical and environmental footprint would actually become smaller despite housing the same research mission. The new station would operate at a fraction of its current $200 million annual budget. Predictable operational costs, lower maintenance, fewer personnel required because everything would be consolidated and automated. But building in Antarctica requires extraordinary engineering. The project would require 150,000 cubic yards of engineered fill, foundation material for docks, runways, building foundations, roadways. To create it, the NSF shipped 2 massive mezzo crushing plants from Finland. They traveled through Germany, then to Port Hueneme, California, then to Christchurch, New Zealand, then finally to Antarctica. Along with 35 earthwork machines, they arrived in February 2024, accompanied by a US Coast Guard icebreaker for safe passage through Antarctic waters. Here's the catch. They could only operate for 6 months, October through April. Then the Antarctic winter arrives and every machine shuts down completely. The crushing plants arrived, produced 150,000 cubic yards of fill, and then the entire operation went dormant until next season. Construction would happen in phases. Year 1, Vehicle Equipment Operations Center, the maintenance hub. Year 2 to 3, 285-bed lodging facility, energy-efficient dormitories. Year 3 to 4, core facility, 261,000 square feet, the massive operational hub. Year 4 to 5, Emergency Operations Center, fire and medical facilities. Year 5 to 6, Field Science Support Center, communications and logistics. 6 years, 6 facilities, complete transformation. By 2025-2026, McMurdo would be unrecognizable. Consolidated, efficient, renewable, sustainable. Built to last 50 years. The plan was bold. The engineering was revolutionary. The budget was secured, the contractors were ready, the crushing plants were already scheduled to arrive in 2024. It was supposed to be America's Antarctic future. Then March 2020 arrived. COVID-19 hit and shut down McMurdo. By late 2020, the NSF admitted the truth. Construction wouldn't resume for 2 full years. The project that was supposed to start in March 2020 didn't restart until October 2022. The 2-year delay created cascading costs. Supply chains disrupted, labor contracts shifted, budget assumptions changed. The bed shortage became catastrophic. The original lodging building had been demolished in 2019, raised to make room for the new 285-bed facility. Except the new building never materialized while construction was halted. McMurdo went from 150 beds, demolished building, plus other dormitories, to a crippling shortage. By 2022, when Ames construction finally resumed, the NSF was forced to admit the truth. The scope had to be scaled back. The timeline extended. The comprehensive vision was fragmented. Of the original 6 facilities, only 1 moved forward with priority. The 285-bed lodging building, still under construction now, scheduled for completion in the 2025-26 season, 3 years later than planned. Everything else was postponed or separated into a different program called AIR, Antarctic Infrastructure Recapitalization. The massive core facility never materialized. The VOC construction was placed on hold. The comprehensive power modernization was reduced to just a switchgear controls upgrade, not the combined heat and power system that was originally planned. The renewable energy transformation was scaled back to a wind feeder connection. The unified water infrastructure remained in the planning phase, unfunded. The vision had been shattered into fragmented projects, most not yet funded. Ames, the $410 million modernization that was supposed to save McMurdo, had been reduced to a single dormitory and whatever could fit into the fragmented AIR program. But that wasn't the end. In 2025, the budget cuts came. The Trump administration's proposed budget for fiscal year 2026 targeted polar research and operations. The Nathaniel B. Palmer, America's only dedicated Antarctic icebreaker, a research vessel that had supplied McMurdo for decades, had its lease terminated. The research support vessels? Gone or aging beyond operational limits. More than 2/3 of the USAP research fleet are beyond their end of life, in some cases by decades. Polar research funding was cut by 70%, from $86 million to $25 million. Every construction project halted. The fragile momentum that had restarted in October 2022 came to a stop again. The lodging building continued barely, but everything else was frozen. 5 years after Ames was supposed to begin, McMurdo Station was in worse condition than when the project started. For the first time in 70 years, America was not building in Antarctica. It was quietly abandoning it. But some countries are doing the opposite. They are expanding. China overtook the United States as the world's leader in Antarctic research in 2022. While America was debating whether to fund a single dormitory, China was building 5 permanent research stations, preparing for a 6th. Expanding geological surveys, increasing scientific presence, filling the void that America was leaving behind. Russia expanded operations with a different mission: resource prospecting. And in 2025, they announced the discovery of 511 billion barrels of oil beneath the Antarctic seabed, nearly double Saudi Arabia's proven reserves and 10 times the total output of the North Sea over 50 years. Germany, Australia, France, every other major scientific power was investing, and the US stepping back. The catch? Antarctica's 1959 treaty bans mineral extraction. It's survived 66 years as a demilitarized zone, a continent dedicated to peaceful science. But that treaty expires for review in 2048. Antarctica contains vast mineral deposits: coal, iron ore, manganese, hydrocarbons, unknown quantities of resources that, in a resource-constrained world, are becoming increasingly valuable. Territorial claims are frozen, not resolved. 7 nations maintain overlapping claims: Argentina, Chile, Australia, France, New Zealand, Norway, and the United Kingdom. The US and Russia maintain stations but reserve claims. China reserves the right to claim territories in the future. Presence is power in Antarctica. Research stations equal territorial claims. Scientific equipment equals resource surveys. Icebreakers equal logistical control. Infrastructure equals influence. Abandoning the logistical capability to conduct ongoing research. Abandoning the infrastructure required to maintain presence and influence when the 2048 review approaches and nations must decide: do we keep the mining ban, or do we access the resources? McMurdo Station represents 70 years of American engineering at the frontier, solving unsolvable problems, building on volcanic rock, anchoring to permafrost, creating systems for -40°C isolation, managing 15,000 kilometer supply chains, building a functioning society in Earth's harshest place. It was extraordinary, and now it's ending. Not because the engineering failed, not because the science was wrong. It ended because the infrastructure investment ran out. For 70 years, America chose to commit. Should the United States invest in rebuilding its Antarctic infrastructure? Or should that money go to other priorities? It's a fair debate. Infrastructure costs money. Budgets are finite. Choices have consequences. But here's what's certain. China is betting that Antarctica matters. Russia is betting that the 2048 decision will be worth positioning for now. Germany, Australia, the UK, they're all betting on Antarctic presence. What do you think the US should do? Comment below. Thank you for watching, and if you enjoyed, please like and subscribe. Every week we tell the stories of megabuilds, the infrastructure that shapes the world. McMurdo Station is one of those stories, and it's still being written. Subscribe to stay updated as this story unfolds. More megabuilds coming soon.